So all is set up. Sorry, I have a minor discomfort on my throat, but well, we can proceed. Okay, music stop. Now, okay, where is my pen? Here, okay. This one. All right. Okay. Good afternoon, or hi, wherever you are. So today I'm going to highlight a few things about data manipulation and how you can read data from multiple different sources, including from web or from SPSS version or from Stata or from wherever you are, from whichever software that you are comfortable with, and then you would like to read that kind of data. Let's say you have saved your data in SPSS version, or in SAS or Stata version, or in Excel or CSV. You can read all of these different data in R. R is really a versatile tool. You can basically read every kind of data. So today we will see how you can read data from different sources, including Excel and CSV, and also from the web. And then later we may see a few points about like descriptive, how you do your descriptive statistics, and then at the very end we may also go through scatter plots and histograms, maybe bar plots, and all with with base R. We are not going to go to a package, but it's nice to know things at the base R level, and then once you you understand the base R, you will be easily able to apply package. Mainly, you would use ggplot2. That one comes because ggplot2 is built, I think, from base R, but to make things nicer and to have nicer graphics, so ggplot2 was created, I think, by the guy who the R community believes as one of the greatest celebrities. So as a quick introduction, we may see a small comparison between multiple different kinds of softwares. So we have different kinds of data or statistical softwares. We can see the main difference and why we need R. I will just summarize it here in this table. So if you are using SPSS, it's mostly point and click. It's user friendly, of course, and the file extension is SAV. So if you read data in SPSS and save it in SPSS version, that means you are saving it as SAV. The file ending is SAV, but Stata has a file ending is DTA. But it's also mostly programming, but you can also do point and click commands in Stata. Whereas in SAS, it's mostly programming. The file ending is it has this kind of structure. I have never used it myself, but I think it's kind of popular software in epidemiology. But it's kind of expensive software. So the last is R, that we we aspire to learn and to make everyone be able to use it, because it's free, open source, completely open. Then it's entirely programming based, and then the data manipulation power is very strong. It's really versatile. As I said, you can read any kind of data. You can scrap website data from using R, or you can manipulate videos in R, or image, so many things. So it's very versatile. And then the graphics, the type of plots, and the quality of the graphs, publication-friendly graphs that you can get, it's is really excellent in R. Where you can also get good graphics from data in the spaces, but they can't be as good as what you can get in R. And all of the others, they are expensive proprietary softwares, maybe affordable for some institutions, or maybe yeah, you may get them by whatever means, but still they are not really affordable. So you need to shift to open access, and that's R. And the most fantastic thing about this, you know, when I see these things, I mean, these softwares, people spend a lot of money for these softwares, but still they can't get the value they can get from something for free. I mean, R offers all of it, all fantastic things for free, but still the other one, still low quality softwares, but you still spend a lot of money for them. Yeah, but it's I think one of the biggest disadvantage of R is it has a very steep learning curve, and that's the main challenge. And if you look at the extension of let's say syntax, when you write your syntax, your data analysis in Stata, if you are Stata user, you know it's a do file, but in SPSS it's SPS syntax. You probably rarely use this type because people usually use just point and click, and they don't save their syntax. But if you really want to reproduce your syntax, you may use this type, but it's not as good as like the other ones, like I mean SAS or Stata or R, where the file extension for your script in R is txt or RMD if you are using R Markdown. But once you are using R Markdown, you can convert your R Markdown file to LaTeX, PDF, or any kind of word processor. You can put it in iOS PowerPoint presentation or in HTML. Yeah, I mean, you can convert all your files to many different ways. You can even produce animated plots and then open them in your browser. Yeah, so that's a lot of things that you can benefit from using R. So a few things, what I want to show you, I mean, this I believe you already know, but if you really want to do, let's say, if you want to do your analysis, you always make sure that always you start with setting your working directory, and then before you set your working directory, you may get your working directory. That's where your files are, what you want to do, where your syntax file should be saved, and so on and so forth. And that's done with get working directory. And the second most important, another important command is set working directory. And this is to select your working directory. You usually use it with this forward slash, or it should be double backward slash. And if you want to see, maybe this one, I rather put it in R, so you can directly see. So I open my RStudio. Let me fire RStudio. Yeah, give me some time, and it's taking a little bit of time. My computer seems busy because of the OBS Studio, I think. This is not what I want because I don't want anything to be open here. Let's say, let me close this and then bring the other one. By the way, you can open multiple RStudios in one. Let me delete all of this and then open a new syntax. Also, let me clear this. I advise, if you are for reproducibility, you go to your global options. Let me zoom it out a bit so that you can zoom it in, so that you can have a better look. So if you are for reproducibility, I advise to go to global options and save this, set as this one as never. So you should not restore any other data in your workspace. So otherwise, every time you start something, it's restoring what you have done before, and it's yeah, it's not really needed if you want to reproduce your results. So this is a first thing first. So we save that. So now let me get my working directory. Let's say my working directory. What is it saying? Okay, let me. Yeah, my working directory is already set where I want, but if I want to set my working directory, you can just, you can copy this from the folder, your path, and then you simply set it as a working directory. And let me see what kind of files do I have. Let's say if you want to see the number of files that you have in your in this directory, you can simply write directory and then run it. So these are the files that I already have in this location in my working directory. That's one really good command. And let's say if you want to create a new directory, you can also create a new directory. Directory create. That means you want to create a new folder. Let's say I want to create a new folder. Let me type it like this, folder. And you can simply run it, simply control enter, or you can also enter here. Yeah, so it's already there. So but it's if I let's say my new folder, if I open this, my new folder, so now I already created. So now if I run this, I will have that my new folder. This is my new folder. So if I go back to my let's say my desktop and open the folder, then if I bring this here, so you see I just created a new folder by just using my new folder. This is my new folder. I just created a new directory. Otherwise, you can also, if you are into Windows, you know how to create a new directory in your folder. But that's you can also do it in R. That's what I wanted to say. And let's say you can also download a file directly from the web. So you can use this download file. And let's say I want to download a file from this Princeton University. I think there is some kind of Excel data about students, and I want to download that data. So you can download that data. Let's say if I download this data, it will put it in my directory. So this is where I have, and it will put it there. So if I download it, and it's telling me that a test file is missing. So to say my test file should be okay. My destination, I think it's destination file. You can enter here. Maybe I can put it like this. Maybe I can put it here. Yeah. And let me call it my Excel file. My Excel file, XLS. And if I do that, it should be able to save it. Now I already have it. I already saved my Excel file, but if you go to my folder, I already have it. So it seems I went to the URL of this website, and I directly downloaded this file. So if you you can also do this if you want to read directly. Let's say data. I want to read directly from the web. So read. I'm not sure whether this is a CSV file, but I can also put it like this. So URL. If the URL is let me put this here. So that's my not actually this one, the URL that I just used from above, this Princeton XLS. So let me use this, and I think read Excel. No, I don't have it. Read X. Okay, let me check if I have read Excel here. I may need to enter. Otherwise, you can also let me go back here and let me just go to my files. Let's say let me go to my files here, desktop, and I go to my online new folder. Let's say oh, it's not detecting it. Anyway, online, and I just put it here. And let's say if I open this, not here, here I don't have any file, but here I have file. So if I use this import, you can also use this as an option. So is this valid Excel file? Of course it is a valid Excel file. But let me, yeah, okay, this is read Excel. I just want to have that that command. It's coming from read Excel package. So for that, I need to do, let me close this. Let me load my library. That's the library, because there are so many different packages you don't need to remember. I mean, you have so many things to remember every day, so I just don't need to remember. So what I do is I call that function, that's read Excel, and then I simply put that URL. So I have URL. It should be possible now to read it. Okay, I didn't read this one. Let me run this. Now it should open it. Pass doesn't exist. Okay. No, I should not put it in quotation marks. So I just need to run this. It's not in my pass, but I need to. Pass doesn't exist. Oh, okay, it doesn't exist. So it seems the pass is not active, probably. But I can also use a different file. Let's say I can go to Google, and I can show you something else. Let's say my Git. I put it here. So this is my, let's say, my blog page. Let's say I have this, not this one. And let me go back to the posters. Somewhere here. So let's say I want to read a CSV file directly from the web. So you can, what you can do is, let's say I have CSV file here. So I open this, and then I go to row. You click row, and you get this this link. So if I copy this, and if I go back to my RStudio and put this one, let's say read CSV, and then the URL is this, the one I just copied from the web. So here you see I am running CSV file. I'm opening CSV file directly from the internet, from my GitHub page. So you see I have 980 observations and 900 variables. You can also view it. Let me scroll this down so that you can have a better outlook. So, and then I have like a lower bound value measure, and this is, it's kind of diabetes global diabetes prevalence for I think from the 1990s until 2017. I think I downloaded this file from the Global Burden of Diseases. But the basic idea behind is I just want to say that you can download a file directly from the internet, or you can read the CSV file wherever if it is available from the internet. You can just use the web link, and then you can still read it. That's one. And the next one I want to show is because I already have this file. I think it was here. Not this one. Okay, it's not here. And for the others, like for SPSS, if you want to read SPSS data, or ZAS or R, Stata, you need a package, and that package is called foreign. So you need a foreign package. It's called foreign. So for that, you can simply type library and foreign package, and then run it. So I already have foreign. And if you want to have some help from the package, as always, you can write help foreign package. You don't need to remember everything by heart. So you can type this, and then you look at the functions. You look at the main functions. For example, this foreign package. Not actually. This should not be in capital letters. It should be like this instead. Okay. Help package. Help package equals foreign. I can simply type it in this foreign. Yeah, so I have the package help page, the package help page for the package. So you can see, you can read many different types of data. So let's say if you want to read, this is for ZAS. That means you need a lookup export. This is a function for reading ZAS file. And if you read WCA, this is our attribute relation file format. I think you may not need this, but if you want, you may probably need this epinfo. If you enter your data in epinfo, so you need read epinfo. Epinfo is usually saving the data in access form, and then from database directly you can use read epinfo. And if you want to look at directly what, let's say if you want to read epinfo. If you want to read epinfo data, then you can simply call this read epinfo, and then you select the file name. If you have, if it is in the internet, you can call URL, and you give it. Yeah, that's basically what you need. But if you want to read Stata, then you can use this read DTA function. So for read DTA, then it's basically all of it. It's similar. The only thing that differs is this one. For read SPSS, for example, you write read SPS. I think SPS. Okay, I read SPSS. So I read SPSS, and then yeah, you save your files. Yeah, and then it will directly read for you. And then the other thing you may need is, let's say, okay, so you can also read it this way. Let's say if you want read CSV, let's say read CSV. It's like if you want to do it interactively. If you want to do it interactively, like the one I show you, you go to the file and then you import it. But you can also do it this way, like read CSV, and then you can write file choose, and then you simply run this. Maybe you can add a few more arguments. That means header equals true, let's say, or you can simply write it true as it is, or just keep it as T, and then you simply control enter. Now it will show me that I need to open, which of the files do I need to open. Let's say I want to open this students file, and I can simply open it. Now it's already open, but I should have saved it as my data. So now I can open it again. So I give it this students data. It's coming from the Princeton University. Now I already have it. It's already open. So this data has it has different columns, like different variable names. I have ID, last name, first name, city, state, gender, and then you have something like SAT, and you can see there are like grade scores, and then I think this is height in. I have no idea what these variables do mean, but yeah. And then this is newspaper. How many times they read newspapers per week? That's probably they want to see if that's related with their average score, their grade. And then you can see age, yeah, and so on and so forth. So that's one thing. So read the CSV, and if you want, you can also, as I said, let me open this. Let me put this here. So you can also read directly from the internet. That's Princeton. Hopefully now it works. Now it's working. You see, it's I have exactly the same version of the data, but I read it from directly from the web. And then, okay, let me zoom out again because it's it's a bit yeah, it's a bit big for me. Maybe for you guys you may be easily see it, but for me it was too big. And the next thing that I want to show is from let's say, so we have already read from the web, from CSV, and then text data. Let's say if you want to read text data, you can use read table. So this is what you need. Let's say I can save. Let me open this file, maybe the other one, because I need to go back to my working directory. So this is my let's say my file, students, and I save this data as text, and then I will open it as let's say, let me save it CSV. Instead, I will put it as text. So it will be no, this one, text dot text. This is Macintosh. This is text. This is what I need. Text tab delimited. So I save it. Students tab delimited file. Delimited. So the ending, the extension of this file is txt, and I save it. So once I save it, I can close this file. I can go back to my R, and then I can simply type a few characters of that file name. It's students, and then I can simply click tab. So you can see my files here. So this is what I need, and then I can simply write header equals true, and then let me save this data again as my data. I'm replacing my data, this one, I'm replacing it. So I can simply run it, and then it should be able to run it, but it's showing some error. So it's I need to give it what is the separator. So the separator for tab delimited is tab. So that means I need to give it the separator command. For that, I just need to use sep equals in quotation marks. So in quotation mark, in quote, no, not that one. I put it this way, and tab. That's what you need. So that means the files, the columns, I mean the between each entry, between each data, there is a tab. So when you save a tab delimited, you always have one tab space, one tab difference. So that's what I need. So tab, and then if you have, let's say, how was the missing value saved? If the missing value, for example, if you are reading in SPSS or something, the missing values might be saved as 99, or maybe like dot, or maybe like you know, like empty. So if you want, let's say, if it is empty, you put it like this. But if it is saved as comma, I mean like 99, so you put it like this. So the NA string, you can mention that, but I don't have any NAs. NA means missing values. So since I don't have any, I can simply run this, and then I successfully read the data. So you see I have 30 variables, and then I mean 30 columns and 14 observations. Yeah, and now you can also write the data. Let's say if you want to write, you can use write. Now we are reading, and the next thing is we can write. So we can write any file in a format that you want. Let's say I can write this. Let's say I have data. I can write it like as CSV, for example. If I want not CSV, I want to write it as let's say text. If you want to write it as a text, you can use the write table. And then you don't need to give a path because I already have my location. What you do is you need to give your file name, what you want to write, save it in a different format. Let's say I have my data. I want to save my data, and then I give it file name. My file name is, let me call it text, for example, and then put it as text. And then what is a separator? I can put a separator, and which is the same as what I had before. So this one here, I can simply copy this, run it, and then it will be automatically saved there. So if I go there, I should have a new text file that's with the file name text. So that's it. I have text. So there are other text files, but this is text and this is text, the one I just saved. Now it's my time. In my time is 1634, so it's like just a few seconds ago I write one file. But if you also want to write, you can also use write CSV, write Excel. Yeah, let's say you manipulate, I mean, you created new variables and you do so much analysis and you created new columns, you mutated, and then you can save the whole thing. I mean, you can save the manipulated data as a new CSV file or text file or Excel file. That's simple. And the next thing is data from Stata. As I said, for data from Stata, you use read DTA. Read DTA. That's what you need to read DTA. And let's say I again use that Preston. They also have it in Stata version. Let's say I use this, and let me call this Stata data. Stata data, and I don't need to change the others. I think the others it should be fine, but I can also you can also use like convert factors true. Let's say if the variable is saved as factor, then when it's read in R, it should also be read as factor. Otherwise, it may be read as character, which is yeah. And let's say if the variables have some, if the variables are saved like, usually R doesn't like space between variable names. Let's say if the variable name is like var name, if it is saved like this, then R, when it reads, it will put this tick marks. So this tick mark is here. One tick mark and then another tick mark. Let's say here. This is, I think this is probably, no, this is quotation marks, but what I need is the tick marks. These are called tick marks. So when you read your file, if the variable names are not properly written, then it will put it in tick marks. Let's say, I mean, in this case, many of them they have like they are properly written, but still, if you have variable names with a space or something in between, then when you read, R put a tick mark so that it will be able to read them. And let's say, let me remove this tick mark, otherwise I will have problem with it. And let me remove it, and then let me read my data. Yeah, so it's Stata data. So I have read a Stata version. To check whether my data is a Stata version, you just need to check the file ending, and that's DTA. That means file is in Stata. If you want to write stata data, what you need is write DTA. So if you want to give, if you're doing your analysis in R, but your friend or your collaborator is prefers to work in stata, you just need to use write DTA. Write DTA, and then you give the file name. That's my file name here, stata data, and then you give it a file name, a new file name. Let's say the stata data for my friend's data. You can give any file name you want, and then you can simply put DTA. That's the file ending. You need that, and then you simply run it. That means it will put it there. Let me run it again, so it will be there. Now I have I should have that data. Yeah, stata my friend. So now I have stata data for my friend. So then he will be able to, or she will be able to analyze in her preferred package. If I want, I can also use a write SPS. Maybe we should come back later to that. And write DTA. So we already use write DTA. And then let's say if we are reading SPSS data, let me go back to the to that Princeton University and show you this SPSS link. That's the SPSS link. That's a version of the file is SAV. This is SAV. So that means they have this data in SPSS version. So to read that data, what you need is this read what was it? Read SPSS. Read SPSS. So you have this, and then you put this thing, the whole thing in brackets, and probably you need the other commands as well. Let's say to data frame. That's one of the things, because in SPSS the file formatting is not exactly like in stata or in R. It's saved in a different way. So you probably need this command, and you put it as to data frame, because R is data frame kind of structure. That means data frame means the rows are the observations and the columns are the variable names. So you need to put it in that kind of structure, and that's to data frame. And let's say use value labels. Let's say if you want, you can also do this, use value labels, but to be honest, this should be working. I'm not sure the default should be true, but you can also change it to, I mean, you can also use as yeah. So let's say use missing. Use missing, that's also another, but you don't need this. You probably need the NA string. The NA string, probably it's not part of this package. Okay. Yeah, so when you write use missing, we can probably look at this read SPSS. So it might be a good idea to look at the package, the function documentation. So here I have the documentation of the function. So you see read SPSS, and it asks me I need the following arguments to be able to read. To be able to read a file, an SPSS version file. So that means it needs to be a file, that SAV file, or a URL with this SAV ending of the file name. And then use value labels. It means it's the logical convert variable with values into R factors. Yeah, this is to make, as I said, factor variables need to be saved as a factor. Otherwise, when you read them in R, they may be changed into character, which you can easily manipulate them later, but you can easily rock them just with one simple argument when you read your data. You always have to. It's very preferable to do that at the beginning of your reading. And to data frame, so it will return a data frame. But if you can also trim. That means cut some of the variables out if you don't want. You can some of the, let's say, factor names, if there is space or something, you can also do that. But I really, to be honest, I really advise to use this library called Janitor. It really helps to clean your variable names. It can also, I think it also helps you to check whether some of the data, some of the observations are duplicated or something. I think for that I would recommend using janitor package. But you can also do it this way. I mean, you can remove space, or if there is a full stop or something, you can also use that. And use missing. I think use missing is to on user defined missing values be used to set the corresponding value to NA. So if yeah, so it should be maybe we may scroll down and see what use missing actually needs. Okay, I think you probably need to write simply true. You can just type true. So if there is use value labels, that means no, that's what I need is use missings, not that one. Use missings, and then you put it like to data frame. That means the use missing, if there is missing data, I guess it's to put this NA assignments for missing values, but we don't have missing value. I don't think we need this. If you have missing value, you may need that kind of argument. And let me save it as spaces data, and then you can simply put it like this object. So I have double P and read it, so it's already there. So now what is this? Spaces data, but it's giving me some error, but this is a kind of ignorable error because it's saying it's re-encoding from CP950. It's some kind of I don't know. I have no idea what is it. So it's spaces. So now I already have it. I think it seems it's a different file, or it must be okay. Maybe I need the other functions. I think to data frame, use value labels. Use value labels. Maybe I need to use this missing. Probably I don't know, because it doesn't seem to read it correctly unless the data frame is a different one, because it should be exactly the same kind of data. Okay, so now again it didn't read it. Okay, there must be something wrong. Anyway, I don't work in spaces. If you are working in spaces, this is what you need. You can have a look at the further detail and check this read spaces function, and then you can do yeah, whatever kind of analysis you want. So to write spaces format from R to spaces, what you need is write foreign. This is what you need. This is the function you need. So write foreign, as always. You can also use simply check. What is? You can simply use question mark or help, and then see what you need. So if you need a package, so write foreign also helps you to write a package data into spaces data or SAS format. Yeah, and then you can do whatever you want. That's it. I think we need to rush a bit so that we can see some of the others what I have. And then data from SAS. Also, if you remember, we were checking for SAS, for reading SAS file. What you need is this lookup export. So you simply need to install foreign package, and then you simply use lookup export. Or you can also do it in HMISC package. HMISC. I have no idea how to read this, but I read it usually. I read it as HMISC. But to read a SAS file, you can use foreign package, and the foreign package is like lookup export. Or you can also use HMISC, and that's coming with SAS export. SAS export. It should be something like this. Yeah, that's export. That's export, I think. I don't have that package currently, but we may also look at it. I think I have it. HMISC should have it. Yeah, because it's a good package for doing correlation plotting, and yeah. So so for that you can use, as I said, SAS export get. SAS export get. if you are a SAS person, then you can use this SAS export get function to read your SAS file in R, which is simple. You can just use this function, and then you read your file name, and then if it needs to lowercase, the variable names, you can just use read this function, this function, and then you can simply implement this SAS export get and from HMISC or lookup export from the foreign package, and then you will be easily able to read SAS file in R. You can also write SAS file. For that, you again use write foreign. That's what you need. Write foreign gives you so many possibilities. I think I was opening this. Probably it's at the very end, so you have it here, write foreign. So it's you will be able to write a file, a data file in SPSS, data, or SAS version, depending on what you want. So if you want, you can just use a package. You can use only one of them, SAS, and then it will be converting your file to SAS, and then you can give your friend if he or she is only able to work in SAS or data, depending on their interest. Usually, when you save a data in R, it's saved as RDTA. This is how it is saved. Let's say if I want to save all my analysis, let's say this analysis is what I do today, so I can save it. Simply, what I do is I can simply save image. And then let's say my new analysis, and then I put extension. My extension is RData, RData, and then the whole thing will be saved in this file. So let's say if I run it, so I should have this file. My new analysis, so I just saved it. It's telling me that I just saved it. That's 1649. And then let's say I remove all these objectives. This is really very helpful if you are working in a very time-taking computation. Let's say if your algorithm, let's say if you are doing on machine learning or something, it's taking a lot of time, and you spend a lot of time, but then you don't want to rerun everything every time you want to see your results. So what you do is, let's say, let me clear all these objectives, let me remove all of them, and then I already saved my file. What I need is I need to use this package, this function. That's what I need. Load RDTA. Load. I just need to use load. Load, and then I use this the one I just used. If I load them, all my objects will be recreated here because I already have them in my analysis. So I just run load, and okay. So it seems what I need is I need to put them in quotation mark. That's what I need. Then load. Now I have regained all my objectives back into my environment. That's very important, especially if you are working on a really time-taking computation or time-taking data analysis. You may not need that, but if you are working on a time-taking, then this is really a very important package. Let's say, I was working in that kind of time-taking process, which takes like 48 hours or maybe 2-3 days. Then this is very helpful. I just need to, let's say, I save my model, and then I put it in save image, and I put my model, and then I save it somewhere, and whenever I need it, I simply load it. It's a matter of seconds, and I can reuse it for prediction or whatever. So we now save data to R. I think what we need is data. If you want to save data, it's the same. You use save data. Not that one. That's not what I want. Save. So you can also save an object. Let's say let's say if you want to save this data, I can simply save simply an object. Let's say you created your model and then you save your, let's say, data, and then if this data is a model, for example, so I can simply write it as save data, and then save and then my object, the comma. And if you want another object, you can also put my data. If you want multiple objects, and then you can put them in one file. Let's say my important objects, my important, or I don't know, my important objects, for example, and then you save them. There is some typo here. You can save them as this, and RDA is what you need. The extension you need is RDA. And now if I go back here, so if I'm selecting only important objects, let's say you don't want to recreate all the analysis and everything, but you can just select some part of your objectives, which really time-taking process computation. Let's say if the model or reading data, if it is taking a long time, you can save them like this, and then whenever you need, you can simply load whenever you need them. Let's say I want to read this my data. What I need is this one. So let me remove the objects first, and then I will load them again, and then you will see that they are popping up. Let me put this in quotation mark, and then let me remove those objects. Let's say remove my data, and then let me remove it. That means I'm deleting it. Again, I'm using ran function to remove data, and now if I run this, I should be able to restore those objects. So now you see I just restored them. So my data and data, I just restored what I already saw. It's a matter of your choice. So if it depends, if your analysis or if your modeling it's the really time-taking process, then you can save. You can use these commands. They are really handy and very helpful. I use them often. And let's say if I want some, let's say now let's start exploring our data. If we want to explore, let's say a summary, I think the first thing you need to do is you need to see how your data is structured. Let's say I don't really recommend to save file as data because data is one function in R, so you don't need to save compete a name with your object. So I recommend to use a different name for saving your data. So let's say if it is data, you can save it as dat or something, but I used data, but this data or data, I think in Australia they call it data. I don't know, I'm not a first English. English is not my first language, but it depends how you read it. So I read it as data. So my data, let's explore our data. So the first thing you need is a structure. The structure gives you how is the variables are stored, if it is numeric or are they in character or something, or integer. It's telling you that kind of information. And then that's the first thing you need to do. And the second, maybe you can also use a summary data, not data actually, my data. I use a summary of my data. So this, it will give me a summary of basically everything, summary of all my variables. Like if it is character, it gives me the number of character, the mode, and probably this is not useful if your variable is non-numeric. But if it is numeric, it's useful because you get the mean, the max, and the median, the third quartile, first quartile, and the maximum. These are really helpful to get a glimpse, a quick glimpse of your data. And then the other one is like you can also edit. It's I don't advise it, but you can also use this, edit my data, if you want to change something. So you get this kind of thing. This like spaces. Let's say if I want to replace this, this person has it's 79 average score. Let me put it like 97, so it's already saved 97. So you can also change directly, but I don't recommend this, to be honest. I don't really recommend changing data this way. Instead, you need to, let's say if you are missing value or something, you need to replace them, or you need to remove them by coding, not by just using edit data. That's why many people don't know this this function. Actually, it's not really yeah recommended. And if you want to see the names of the columns, you can use names, my data. I'm just starting from the basic, and I'm repeating over things over and over again, so that you can master it. So these are really the basics. So you see my variable names, they are here. And then if I want to see head, let's say my data, the head of my data, let's say head gives me 6 observations. So if you see 6 observations and their score, you can see. And the tail, if you use tail, that means the last 6. So that means you can see like this. Or if you want, let's say head, if I want to see only, instead of 6, only 6, only 3, or maybe 20, or whatever, you can just change, add comma, and then you can just add whatever figure you want. Let's say I want to see only 2 observations, and I can see only 2 observations. Or if I want to see the last 2 observations, then you can see like this. Yeah, simple. And let's say you can also do it this way. My data, my data, and then you do this square brackets. So everything, let's say like this, you put like this. So everything before the comma means observations, and everything after the comma means the columns. Let's say if you want to see the first observation and the 6th column, you can use like this. So my data, so that means it's female, the female person. And if you see second observation, say second observation, and no, 8th observation, and then third variable, let me say you can do this, and that person is Jones. But you can also do like this. Let's say from observation number 1 to 8. That means you want to see 8 people, what they are, and I mean what is their name. And then let's say you can also do this way. From variable 1 to variable 3, 8 people with 3. Yeah, you can also do this. I mean, and then you can put it as an object. Let's say subsetted data, because it's subsetted data, both in columns and in terms of yeah. So you see my subsetted data has 8 observations and 3 variables, and I just subsetted it. Yeah, that's it for exploring. And you can also explore your workspace. Let's say if you want to see the number of objects that you have, how many objects or what kind of objects do you have, you can use list, and it gives you all the it should be not list, sorry, ls is the list of all objects. Then you give it gives you all different objects that I have. So I have data, my data, spaces, and so on and so forth. You can also use objects. I think the good thing with R is you get the same results by using different methods. I think that's the advantage. So you do something in many different ways. So you see objects, or you see, or you can use ls. And to remove, I already showed you. We use rm. Let's say if I want to remove all these objects in my library, what I can use is remove. In my environment, I want to remove all of them, and you can just simply use ls rm, and simply list equals ls. So that means I'm removing all of them, and just once I can delete them. So I cleared my library, and then I can go back to my previous command. If you remember, I was loading them. Now I'm loading them again. I can again load them. So now I have everything back. And I think what else do you need? If you want to remove package, let's say to install a package, you can use install package. That's what you need to remove a package from. Let's say if you don't need it, you can use remove package. This is what you need, and then you write the name of the package. And then to load a package, you use library. I think we have seen that. I'm not going to go to that one. And if you want to see missing value, let's say let me assign some missing values. Let me say my data. I think age is one variable, so let's say my data age. Okay, which ones? Let's say from 1 to 4. From 1 observation to 1 to 4, I will assign them as NA. The rest will be kept as it is. And now if you go back to my data and then see age variable, so it should be NA. So you see I replace them with NA, missing values. So I can remove them like that. So if you want to see the number of missing values in my data, so I can use sum is NA. That means whether there is any NA, and then I can use my data age. So that will give me okay, sum is NA my data. Is NA okay, sorry, this should be like this, true? But I have missing values in this variable. It should be giving me 4. Maybe I missed one something. Sum is NA my data age variable. Okay. Or it should be giving me like that. Sum is NA my data. Yeah. Anyway, it's not giving me. But it's usually this is what I use. Sum that means the total number of missing values in my age variable, and it should give me 4. It should have given me. Yeah, something is not working. And then I think what we can do is like renaming variables. Let's say if you want to rename, let's say if I want to rename age, what I can use is like I think you can use reshape for that to do rename. You can use a reshape package. Reshape. I can use a reshape, and then let me use rename. Let's say let me do this instead of typing all because I already did it once. So I can use it like this. So let me use my data rename. That means my data. So last name I will call it as last, and my data first name I will save it as first. Then if you go back to my data and then see, so these are renamed. Or you can also use this function called clean names from janitor package. So you can just go to my data, and then save it as clean names. Clean. Maybe I should load the package first. Library janitor. Yeah, now it's already saved. So now I should be able to use that clean names function, and then my data, my data. Yeah, now I should have my variables should all have clean. That means the variable should have a lowercase and separating space or tab or any kind of should be replaced by underscore. And this I have just one function, one small function, just one, and it's cleaning them everything. And this is what you need. Yeah. And then I think if you want value labels, let's say if you want to, sometimes this might be important. If you, let's say if I want to reorder, give value labels for sex, let's say if it is 1, give it, first I need to check table. my data sex. It should be, I should have sex variable, I think. No. Okay. So it seems I don't have. So I don't have sex variable. No, I have like female and male. So it's written as gender. So instead of sex, it's gender. So my data, I will put this as gender. It's gender. And then you see female 15-15. They are perfectly balanced. So then I will put this one as gender and may save it as sex. And then you see my data gender labels are C1 and 2, and the labels are male and female. I can exactly convert them like that. And then if you look at my data, it should be at the very end of, oh, okay, it didn't convert them properly. But maybe because my labels were not right. So let me labels male female, and if I go back, still I have problem with that. Okay. Factor my data gender. C1 2 labels. Yeah, anyways, this is how you save it, but also you can also put it this way. My data gender, my data, there are many ways of doing the same thing. I think that's the advantage of using R. If else, and then my data gender equals, let's say, female. Then I will assign it as 1, otherwise as 2. Then should be working. So if you see, if I go back to gender, my data, and if I check gender, okay, what was my variable? Gender. Oh, I see. So I already replaced the data, the original variable. That was not what I want. Okay. My data, if else, my data gender, if else my data gender equals female. So I made a mistake. So this is should be, let me put it as sex, and a little misspelling error messed your syntax. So you see now I already have it. So it's like 1 and 2, they are saved as I want. And you can also see like labels. What kind of labels do you have saved in your data? Let's say you can also see labels, or labels, I think, labels. And I think we can pass this and rather go straight to the main, like putting visualization and things like that. That's probably what you need. And if you want to see like a dimension is how your dimension of your data, say how many variables and observations. Like my dimension of this data is 30 observations and 15 variables. And then you can also do it this way. Dim, let's say if you want to extract the number of total number of columns, you can use like this. No, that's not what I want. Sorry, 1. That means first dimension is the number of observations. Second dimension is the number of columns. You can also do it this way, but this is not really very helpful. I don't think you will need it. And then maybe if you want to sort, like sorting a variable, like data, let's say if you want to sort them, you can use is my, let's say my sorted data, my sorted data like this, and then my data then I will simply use this square bracket, order my data, then my data by what kind of variable. Let's say I want to order them by their score. Let's say I can just go their grade. Where was it? Yeah, here. And if you want to put them by ascending order, so you can put it like this, minus sign, and then it should be possible like this. Let's check if it works. So sorted data, my sorted data, and if we go back and here you see the person with the maximum, the highest score. I mean the highest score here. That's the value that we need. So average score grade. The person with the highest is sorted from the top, and the ones with the lowest score, they are at the very bottom. Probably this is useful if you want to have a quick look of your data. Otherwise, yeah, you can also do it better in arrange, using arrange and deploy. That's sort. If you want to put them as ascending order, you can remove the minus sign and you run it, and then you go back and see how your score is arranged. So you see the one with the minimum score 67 up to 96 are arranged. And let's see what else. Deleting variables. If you want to delete a variable, let's say if I want to delete the sex variable, what I need is I can simply put it as null and it will disappear. So you can simply put it as NA and it should disappear. Null. This is what you need. So if you remove this, that means it's already disappeared in my variables. So you see my data has 14, but the other one has 15. So one variable has disappeared from my list. And subsetting, I think subsetting we have got a quick look, but I think for subsetting it's better to do a deployer like filter or something. But otherwise you can use this superscript way of subsetting like this. Let's say if you want like this, for example, if I want to my new data, not that one here, and then you save it like this, my data, which when the which command could be useful here. Otherwise it's kind of complicated, but with deployer is much easier. So it's telling you my data gender equals female, and that score greater than 1800. So you can filter data as giving me 0 observations, but I can simply leave this out. Probably I don't have one of them. Okay, I probably okay. Let me check. Maybe gender is saved differently. Maybe. So my data. Let me check my data. How gender is. Yeah. Okay. So let me use a different name instead. So major, country, or maybe country US. Let me use this country variable. So country and US, and then maybe I can remove this, and then you should be able to do all US people. So I have all of them here, but you can also extract the other variables that with end and with some logical that was saved as SAT in small letters. Otherwise we will have a problem. So for that I just need to type it exactly as it was typed. So now my new data has 11 observations, and it's filtering the data with people having that level more than 1800. That's how you filter it. But for filter, to be honest, it's much handy in deployer. So we will see it later, maybe in the next in my next sessions. I think I prefer to go directly to the visualizations. So let's say descriptive statistics. Okay, we are running out of time. And let me say, if you want, now I want to show you is like visualizations. Let's say if you want histogram, you can use hist, and let's say my data age, and then you run it. X must be numeric, so it's not saved as numeric. So then for that you need to ask, is numeric my data age, yeah, false. So then you need to change it here as numeric. You need to parse it as numeric, then you will be able to have the histogram. So now I see my histogram doesn't look nice because I was compressing my viewer. So you see it's a rough look of my histogram. But if you want box plot, you can also use box plot like this, and then you can have this kind of box plot. So you can see where the median is, and then the max and the mean, and you can have a quick overview of your box plot. If you want to have a scatter plot, let's say if you can use scatter plot, you can also do scatter plot, 3D scatter plot. You may I think what you do is plot. Let's say let's go back to this empty cars data. I think that one has good variables to show. Let's say empty cars with mpg, miles per gallon, with HP. And then we can run it, and you see this is my my scatter plot, how it looks like. So you see there is some kind of pattern here, but I can also change how these values need to appear. So I can change the size, CX. I think CX is the one if you want to change the size of these plots. So now I made them bigger, so they are bigger. And if I want, I can also use alpha. I think alpha is for transparency. Yeah, I'm not exactly sure, but I think you can have a look for the cheat sheet. It has so many things. These are cheat sheet. These are you can simply Google it. And this is the cheat sheet. This is what you have. So you see. These are the cheat sheet. No, that's not what I want. These are plot cheat sheet. This is what I want. So you see here, these are the basic, really everything in one page, packed. So let's say if you want to change, we just use CX if you want to change the size of the plot in scatter plot. But if you want to change the shape, you can use PCH. I can use PCH. PCH equals let's say I don't know, 5 for example, and it will give me a diamond shape. So it's giving me this square, or I don't know, diamond kind of shape. You can go back to that cheat sheet. You can have a look and change. There are 25 different shapes. You can change them in any way. But if you also want like to add a new plot, you can add multiple line plots in one. You can just simply add them, add equals to. I think I suggest everyone to have a look at this cheat sheet. It's it has really almost everything you need, a basic summary of everything you need. So, and I probably need to look next is let's say scatter plot. What else? My data age. Let's say we can see plot. Maybe like let's see it here. Plot age versus this score. My data. Unfortunately, they are not saved as numeric, so let me save them as numeric. My data, and then age versus as numeric again. I need to make sure that they are saved as numeric. My data, and then let's say score, what was it, this grade, and see if they have any relationship. Yeah, there seems there is no relationship, so it seems there is nothing. You can also see correlation if you want. It's no, that's not what I mean. Chord plot is something. So there is some kind of NA somewhere, so it's not working. But my purpose now is to show the plot. Not PLT is a Python function, not plot. Is it not working? I see. Okay, it's already deleted. So if you want, you can also see that with that, for example, and then see if there is any kind of relationship. Yeah. So it's if there is any missing value, it still plots it, but you will see this kind of error message. But still, it's kind of ignorable error. Let's say if you also want, I think we can also see. I think the last one I want to show you is this 3D scatter plot, which might be useful, but interpreting 3D scatter plots is not really easy. So you need to first load the current data set. For the data, we need to have a car, because we need to have the prestige data, and then we can simply scatter 3D, and then from there you can use prestige and as a function of income plus education, I think education, and then ID IDN equals 3, and the data is what was the data? Duncan, I think, if I remember correctly. Yeah. Now you may have if you run this, you may have problem. You may not have a package, so it may give you some kind of error. But otherwise, if it gives you need this package, and this package, you just follow the package, you copy that error, and then the name of the package, and then you can simply install it, and then you should be able to. Now it's giving me I need RGL package, so I need to load RGL. So what I need is I need to load my this RGL package, otherwise I cannot run it. So I need first to load this, and then let me see if it works. Now again, it's telling me invalid type of list variable, prestige. Okay, scatter model default invalid. So I already ran it here. Scatter 3D. It should work. Prestige, income, plus education, IDN equals 3, data Duncan. Okay, it's not working. Let me check the documentation. And if you look at the documentation here, it's telling you scatter 3D function. Maybe they have example. We can just go scroll down and find out if they have any example. I mean, that's I don't think you need to use it. It's kind of something to make you interested in R. Let's say, I mean, okay, probably it's small letter. So I think I think I made a mistake. This should be small letter. So you see, I just made a typo here, and it's not running. So now it should work. Oh. Okay, now it worked. I just need to bring it here, so then you can have a look. So it's kind of fancy, but I don't know if this is publication friendly. You cannot publish it in a paper because it is a 3D plotting, and interpreting it is also it's complicated. So I don't believe you need it. But for that, I think what you need is Plotly. Plotly package. Plotly has so much interesting functions, but that's based on ggplot2. So let's say if you want library, let's do something here. The last one, library ggplot plot2, and then let's say we need empty cars data. ggplot, what you need is, the first thing is you need to have the data. The way ggplot means, I think we can have a great overview in the coming sessions, but let me give you the x variable could be mpg, and the y variable equals let me give it hp, and then what you need is a geom function. Let's say if I want a scatter plot, I can do geom point, and then let's say if I want a color variable, like to differentiate them, then I use a cyl, that's a cylinder, I think, and then should be able to run them now. So now you see this kind of plot, but you can pass this library to plotly, I think, plotly, and then you can simply plotly, I think. I'm not sure this is the right way of doing it, but yeah, let's see. It should work. Okay. Username as environment variable. Okay, no, this is not how it works. So let me say p1. Let me save it as p1, and then yeah, now I already have my object, and then see, yeah, plotly p1, and now okay, it's not running yet. Yeah, anyway, plotly username. Let me check plotly. Okay, what you need, username and key. Okay. Oh my god, oh no, this is not what we need. Sorry, I forgot. ggplotly is what we need. ggplotly, because plotly is making its money, so you probably need to use a username and to use the API. They also have a nice I think they also have nice API for Python and other users. You can Google them. They really have nice platform. They basically change almost graphs into very interactive and nice graphics. I really recommend looking at their library. I think this is for Python, but you can also look at their functions, I mean their graphics for R. Yeah, so anyway, they are really interesting, very fascinating library. So for that you need ggplotly, and then you pass your plot. Then you see you can have an interactive kind of plot. So you see, I see every time I move the points, you see which point is at that particular point, how much is the MPG, HP, and CYL variable, and they see all of them like that. And it's kind of interesting. You can also put it like this. Here, ggplotly, and then you pass the whole ggplot function here. I think don't worry about ggplot. We will have time for it, I think. Then you can also do it this way. Instead of putting it as a separate object, you can also do it that way. Last development, not least, I think that's all. We probably do next more sessions. I think for the next one I will do like data manipulation using going into detail into like libraries like dplyr. That's what you mainly need, dplyr. And then once we have that, we go to ggplot visualization, and then once you are able to visualize and see some kind of pattern in your data, then we can go to linear models, the logistic regression, linear regression, and other models. Let's say missing value replacement, like using mean, median computation, or maybe like random forest, things like that, to impute like advanced methods of missing value imputation. But this is really the basic. What I did so far is like really very basic that you may need in at the start. So if you revise that, I think you will have a good journey of RStats. I hope we have a good day. So maybe in the next section we can have other sections. Otherwise, yeah, I wish you a good time. So. Mm-hmm.